to free up that memory whenever the usage of that memory is done. So you have to manually free that memory. The compiler does not automatically deallocate that memory. So this is a very important step. If you miss freeing up a memory, it might lead to memory leaks. That means that memory will never be deallocated and it cannot be used by some other program, which is an execution. Okay, so I'll just quickly show you the example of calloc, malloc, and realloc. So this is the program which I've written. So this is, I am creating a pointer malloc array of size 3. Okay, and using malloc. Okay, so now here I created a, array of size 3 using malloc. So now this will not be initialized because we are using malloc. So it might contain some garbage values and it might print some garbage values. Okay, this is how we can allocate memory. So now if we use calloc to allocate an integer array of size 3. So now after using calloc for memory initialization, we will get, it will be initialized to 0. So whenever we will print, the data will be printed as 0 because we have used calloc. And if you use realloc to resize, okay, some existing memory. So resize some existing memory. Sorry, this is a realloc array. So this is the realloc array which I created earlier of size 3, and then I use realloc to increase the size to 5. Okay, now when we increase the size to 5, the data which I stored in this loop will be preserved, but the two memory blocks which got added might contain garbage. Okay, so I'll just quickly run this program to see what all things are getting printed. So malloc is also printing 00. So there might not be some garbage value because we are running on an online compiler, but it might throw some garbage value if you are running on your local or something like that, right? So it might or might not have garbage value. Calloc will definitely print 0, and realloc, it is preserving the existing values which we gave to it, and for the further two memory blocks which are getting added, it will print either garbage value or some 0, right? So it might be garbage, it will not always be 0, right? Right now it is 0 because I think so we are using online compiler, it is due to that. So otherwise it might throw garbage values here. So is everybody clear with dynamic memory allocation and the workings of calloc, malloc, realloc, and free? And you can observe, right? After using everything, I am freeing all the memory which I dynamically allocated. Guys, do you have any questions? Okay, if there are no questions, we'll proceed ahead to the next topic, which is, okay, so here is some example which I've already shown you. So we'll move forward. So now the next thing. So like we are trying to revise all the topics which you have already studied, right? So I will go through all of them. Okay. So if you feel right, you don't understand, I'm assuming that you've gone through all the articles that were given to you for this particular week. Okay. And then you're trying to attend the session to just revise it. So this is a kind of revision. So I will go through all the topics quickly. So if you feel anything that you're not able to understand, just interrupt me and you can ask in detail. That's what I can help you out with. Cool. Okay. Now moving to the next set of things, which is user defined data types. Okay. So in the first class, if you remember, if you attended the first session, we discussed data types. Okay. And in data types, I told you there are broadly three categories of data types. One is the primary. Second one is the secondary. Please don't mind my handwriting. It's not very good. And sorry, not secondary. My bad. It's not secondary. It's primitive, not primary, secondary. It's primitive. Primitive. The second category was derived. And the third category was user defined, which is this user defined data types. So primitive data types were character, integer, boolean, long, all of those were uh, primitive data types. Okay. Now derived data types we studied in the second session, which was arrays and pointers. All of them are derived data types. Okay. Which are derived from the primitive data types. User defined data types are the data types in which the user defines the data type, right? So we can make any data type and we can put all the data that we want to put, right? We can structure it in any way that we want. So those are the third category of user defined data types. So today we are going to discuss two things in user defined data types. First is the structure and second one is the enum. Okay, so as C is not an object oriented programming, it does not have any classes and object, but it has something similar which is called structure, although there is a huge difference between structure and similar structure and classes, but to look right, so the look and feel or if you look at a class, it will look similar to you as if you look as a structure, it will look very similar to a class, right? So we are going to discuss structure and enum. Okay, so we'll first deep dive into the structures, right? So what are structures? So structure is something, so let's say if you have a lot of related data and you want to put it into a packet, or you can say you want to do a encapsulation of that data, right? For example, you have data, let's say for a person, you have data as name, age, let's say address, blood group, or whatever, DOB, date of birth, and a lot of things, right? So all these data are related because all this data belong to some person, right? And similarly, for some other person, you have the same data, name, age, address, date of birth. And for the third person, you have the same data, which is name, age, address, and date of birth. Now, what you can do without user defined data structure, what you can do, you can define a string name, age, address, date of birth, whatever. But you can define name 1, name 2, name 3, age 1, age 2, age 3, address 1, address 2, address 3. But now how do you relate the data, right? So it becomes very difficult to encapsulate this data together because these are related. So in order to do that, what you can do, you can define a structure, and inside the structure you can give the name of the structure as person, and inside that structure you can put name, age, address, date of birth, all of those things. And whenever you're defining a person, so you will define a structure, and inside the structure you will keep name, age, address, and date of birth, right? I'll quickly show you an example. For example, here we have created a structure named student, because every student will have some ID and some name associated with them, right? So now these two data are very closely related and I want to encapsulate them under a single name or single data type. So I created a structure in which I will keep two data, which is ID, an integer type, and second would be a character array or a string, which will contain the name of that particular student. Okay. Similarly, you can create multiple students, student 1, student 2, student 3, or an array of students, because now the data type will not be integer, character, or something. You will use data type as student to declare that particular student. Okay. And if you want to add more things, you want to add age, you want to add address, whatever you want to add, you can add it in this particular structure, and you can use this structure to define that particular student. Guys, any questions on what is the structure, anything related to structure? And whenever you have to access a particular structure, okay, so you can access it using like whatever variable you create, student.id, student.name, and so on. Just a minute, I will just try to give you an example. So we'll go to the this. And then we will try to open one compiler here. Okay. So now we'll go to the new and we will select C here. Okay. So I'll quickly try to create a structure here. Hash include, I will include string.h. So struct person, and then I will give some data type to it. Let's say character array, name, and let's say the size of this name would be 50. And then int age, and then let's say float height. Okay, these three properties I gave to this particular structure. Now, whenever you have to define a particular person, you don't have to write integer character name, integer age or something, right? What you will do, struct person will be your data type because that's the user defined data type you have created. Person one, I will name this variable as person one. Okay. Now, what I have to do is initialize. Right now, it hasn't been initialized. So, strcpy I will use to initialize the name person one dot name. You can access the name property like this person one dot name, and I will put it as sorry. And then I will initialize the age person one dot age is equal to 25. Person one dot height is equal to, let's say, 5.9. 5.9 I will put. Okay. And then you can print whatever you want, right? If you want to print uh, name, and if you want to print name, how will you access the name? Person one dot name. Okay. So it should print name as Saurabh. Okay. It's giving error. What is the error? Int main should return. What did I do wrong? It should return int main expected. Okay. Somewhere I missed something. Printf. Okay. Oh, sorry. Slash n I missed. Yeah. Int main, where did I miss? Okay, yeah, here I missed the semicolon. Okay, so name Saurabh is getting printed. So if you want to print age, you can similarly print age, and height, same way you can print. Age you can print hyphen D, sorry, percentage D, and here you can print the age. And similarly, you can print float as this float is height, HEIGST height, and this is HEIGST height. The height will be printed as minus something. What did I do wrong? Oh, sorry. Person one dot height should be 5.9 F. I'm not sure why this is printing some negative value. person1 dot height is equal to. Okay, anyway, right. But did you understand, right? This float, high, sorry, all this structure thing that you can understand, we can give some value, right? I'll need to figure out why this is throwing negative value. Okay, sorry, I did not do percentage F. I did minus percentage. That is why it is printing. So it should be 5.9. Okay, so this is what structure does, right? Anybody any questions here, guys, in structure? So you can create similarly whatever. So this is called a user defined data type, right? So now we'll come to enum, right? So now enum is, let's say, for example, here I give a gender. Okay, so if let's say I give char gender and let's say some 10. So what this can do is a lot of people will put M as gender. A lot of people will put male as gender. A lot of people will put F as female genders. A lot of people will put female as the gender, right? So will not have a predictable set of values which can be used here. Okay. So now for that, in order to solve that, enum is a data type which is used to give some value, predictable values, right? So there is a set of values that we define in that enum. And if we define the data type as enum, so only those values can be used as the value of that particular data type. For example, if we define enum here as, let's say, enum gender, okay? And gender will contain, let's say, male, male, comma, female. Okay, and here we'll create a data type called gender, and gender may we will create, let's say, gen, or let's create gender as capital gender. I'll keep it, and this will be capital gender. Generally, user defined data types we give capital names to them, right? So here gender. Okay. Now, whenever you are initializing gender, you can only put values as male or female. Any other value will not be accepted, right? So here person dot one person1 dot gender is equal to male is what I can put. And if I try to print, right? Okay. Now, can you tell what will be printed as gender? Guys, can anybody tell quickly what will be printed as gender? Nobody has any idea. So actually 0 should be printed as gender because enum is nothing. Basically, it assigns some ordinates to every value that we give. And the ordinates by default are assigned as 0, 1, 2, 3, 4 in that order. Okay. So whenever you try to print them, it will print the ordinate of the enum, right? So it should print 0. Okay, what did I forget? Okay, sorry. I should have used curly braces here, not the parenthesis. Gender. I should not. Oh, sorry. We'll have to put this thing, right? Yeah. So it will print 0 because 0 is the ordinate for the male. And if we assign it female, then it will print 1 because 1 is the ordinate for female. But we can assign some other ordinate if we want, right? Let's say I want to assign 20 as the ordinate for male and 25 as the ordinate to female. So now 20 will be printed for male and for female it will print 25. You can see, right? So internally enum assigns some ordinate, and after assigning the ordinate, what will happen is the ordinates are used to identify, okay, what enum it is, because it's optimal for the compiler to use the ordinate instead of the actual names. Okay, so any questions in the enum? So this is also a user defined data type because user is defining this data type. Guys, any questions? So enum and structure is clear to everyone. Okay. If enum and structure is clear to everyone, so similarly here we have defined the enum called color red, green, blue. You can define more enums, right? Whatever you want, right? Okay. If there are no questions on enum and structure, so we'll move on the next part, which is the one data structure, which is called stack. Okay. So what is a stack? So stack is a data structure, a linear data structure. Okay, which looks like a list, okay, but it differs from the array in the fashion in which we insert and delete elements from stack, right? So stack follows the LIFO, last in first out principle, to insert and remove elements inside and out of stack, right? So you can consider stack as a jar. Okay, jar means it is closed at one end and open at the other end. Okay, so it's a jar of cookies, right? So the cookie that you keep first inside the jar will go at the bottom. Okay, and the second cookie will come on top of that. The third cookie will come on top of that. The fourth cookie will come on top of that. The fifth cookie will come on top of that. Okay, yeah, guys, just give me a minute. Yeah, sorry. Now coming back. So yeah, the next cookie will come on top of that, right? So now while you're removing the cookie, right? So you will end up removing this cookie first, not the cookie which you put the first, because the first cookie is at the bottom. Okay. So now the cookie which was inserted the last will be the first one that will come out. And after this cookie has come out, the second last cookie will come out, and then third last cookie, and so on. Okay, so whatever cookie that you put first will be the last cookie to come out. Okay, so that is why it is said last in first out. The cookie which was inserted at the last will be the first one to come out. So this follows the LIFO principle, that is last in first out. So I'll just give you an example. So let's say you create a stack of integers. So this is our stack and this is our integer. Okay, so this is and it is a stack of integer, and I want to insert elements 1, 2, 7, 3, 5, 9 in this order. So firstly, I will insert 1. So 1 is the first element to get inserted. Then I will insert 2. Then I will insert 3. Then I will insert 7. No, so 3 is not there. 7 is there. Okay, then I will insert 3. Okay, now currently in the stack, firstly I inserted 1, then 2, then 7, then 3. 3 was the last element which got inserted. So, but currently what is the top of the stack? The top of the stack is 3. That means 3 is sitting at the top and 1 is sitting at the bottom. So the element which we inserted the last is sitting at the top, and the element which we inserted the first is sitting at the bottom. Now if you want to remove an element, the last inserted element will be the first one to get removed. So the topmost element is 3, and 3 will be the element if you want to remove, will be the first one to come out. Now if you want to insert one more element, then 5 will come here, then 9 will come here, and now 9, if you want to remove an element, 9 will get removed because 9 is the topmost element of the stack. After that 5 will be removed, and so on. And at the end 1 will get removed because it was the first element which went inside the stack. So this is what a stack is, a linear data structure, which you can consider as a jar, which is uh, closed at one end and open at the other end. And the entry and exit gate are same, right? So this is the gate from which you will enter the elements, and this is the same gate from which you will remove the elements. Okay. And it follows the LIFO principle of inserting and deleting an elements. Okay. Is everybody clear of what is a stack? Any question? Yeah. So now, whenever we are inserting an element, so a stack should definitely or mandatorily implement two functions, which is a push function and a pop function. What is the functionality of a push and pop function? So with the help of push function, you will insert an element inside a stack, and with the help of pop function, you will remove an element out of the stack. Okay, I'll repeat again. With the help of push function, you will be able to insert an element inside the at the top of the stack, and with the help of the pop function, you will be able to remove the topmost element out of the stack. Okay, so these two functions should be implemented definitely or mandatorily whenever you are implementing a stack. Okay, and with this we can implement some other helper functions, such as what is the top of the stack. Then you have to tell, so you have to implement a function called top of the stack, right, which will be this. You can implement a function is empty, is full, to identify if a stack is already empty or a stack is already full. Okay, all these functions you can implement. So now, any questions on the principle on which the stack works? Okay, if there are no questions, then what we will do, we'll quickly see an implementation of the stack using arrays, and then we will move forward to queues. Okay, so this I'm using the help right of the GFG article to explain the implementation of stack using arrays. So here you can see we defined a structure called stack. This is again a user defined data type structure. Okay, so we defined a structure and we are using type def. So whenever we use stack, we don't have to write struct everywhere. Okay, so we can directly write stack. So because if you remember in this example, we have to write struct everywhere whenever we were declaring person. But if we use type def, so we don't have to write struct everywhere. We can use only person to define a data type called person. So that is why here I've used type def struct, and this is stack. So now the first function to initialize the stack. Okay, so the structure contains an array, okay, which will have which will actually store the values. Okay, and max size is defined as 100. Okay, and the another value is top of the stack. So what is the current top of the stack, right? So what is the element which is at the top of the stack? It will store the index of that element. Okay, so now we'll go to the first function, which is initialize the stack. So whenever you initialize the stack, you pass a structure here, and with the help of that structure, I'm passing the pointer to that structure. Okay, and with the help of that pointer, I am initializing this, the top of that particular stack, as -1. -1 means there are no elements inside the stack. Okay, and the stack is empty. So initially when you initialize the stack, it is empty. So everybody understands this annotation to access an elements in a structure or a pointer. Guys, if anybody does not understand this annotation, you can let me know. I can explain you what is this representation means. Okay, I'll quickly tell you, this representation is equivalent to writing. So let's say here stack is a pointer. So if I want to access the stack, so this is equivalent to writing. If you're writing star stack, because stack is a pointer, so you have to access the stack, you have to use star. And in order, so stack is also a structure, so in order to access some value inside that particular structure top, then what you have to do, you have to use dot top. So this annotation, this not annotation, this representation is very similar to, you can write this as, the equivalent form of this is this also, right? So you can use stack top. So both of them are same. If you're writing this, if you're writing this. So this is a cleaner approach. So that is why a lot of people prefer this. Okay. And that is what we have used here, right? So stack dot top is equal to -1. So now is empty. We have created a function which is returning a boolean. It is telling you whether the stack is empty or not. So if your top is equal to -1, then you will return that, okay, the stack is empty. If top is not equal to -1, so this will return false. Fine. Now coming to is full. If this your stack is full, then you will return true. If your stack is not full, then you will return false. So if the top of the stack is max size -1, because we are following a zero based indexing. So that is why max size -1, if it is equivalent to the top, then we will return, okay, true, the stack is full. And if it is not equivalent to this, then the stack is not full. Then we will go to the main function, push and pop function. So in push function, you are given a stack and a value to be inserted inside the stack. Okay, so what you will do, you'll first check whether the stack is full or not using the is full function we just defined. So if the stack is full, you can print, okay, the stack is already full or stack is overflowing. So we will not be able to put element inside the stack. Okay, so you will return it from there. But let's say if your stack is not full, this returns false. Then what you will do, you will go to the stack.array and you will increment the top and store the value there. You will increment the top of that particular stack. So let's say initially your index was equal to -1. So the first element will get stored at index 0 because this plus plus stack dot top will make -1 to 0 and it will store the value as 0 at the top of the stack. Now pop function, pop will do stack. It will take a pointer to stack. It will check if the stack is already empty. If the stack is already empty, we cannot remove an element out of the stack, right? So what we will do, so we will return, we will say, okay, stack underflow means stack does not have anything. So we will return -1. That means we cannot pop elements outside that stack. Okay. Otherwise, if the stack is not empty, what you will do, you will store the topmost element in a variable called popped. You will decrease the top. That means now the top of the stack is getting decreased. Whatever was the top of the stack is no longer part of the stack. Okay. And then you will return the popped value. You will print the popped value and you can return the popped value. Okay. And peak, this will return the main, the topmost element in of a stack. Okay. So the peak may we are passing a stack. It will check if the stack is empty. Then we'll say stack is empty. If it is not empty, it will return the topmost element of that particular stack. Okay. Any questions, guys? So now you can see here, this is the main driver function. We created a stack. You can see here, we don't have to put struct, because we used a type def here. Type def means whenever we are saying stack, it means this structure only. So we don't have to use struct here, which we were using in this example. And if we create a type def of enum, so we don't have to write enum here. We only write gender and it will be understood that it is referring to this particular enum. Okay, then we are initializing the stack, passing the address of the stack, and then we are doing push, then peak, then push, then peak, then push, then peak, then push, then peak. And then we are removing all the elements and popping them out. Okay, that's what this particular implementation of the stack using arrays. So guys, any question in any part of this particular implementation using arrays, implementation of stack using arrays, any concepts related to stack is not clear, you can ask the question. I am happy to answer them. Okay, if everything is clear, then we will move to the next data structure, which is called, again, one thing to remember, whenever you're implementing a stack, then all the functions that we discussed should be implemented in big O of one time, right? It should not cross big O of one time. The expected time complexity of every function, including push and pop, is big O of one, right? So if you are using big O of n or greater than that as your time complexity, then it's not a properly implemented or optimized stack. Right? So you can see all the functions that we are using, all of them are big O of one operation. Clear? Okay. If this is clear, we will move on to our next data structure, which is called queues. Okay. Again, I will try to summarize queue for you. If you have any questions, you can ask me. I'll try to answer those questions for you and I'll try to clarify it to you. Okay. So now, again, similar to stack, queue is also a linear data structure. The only difference being queue follows the FIFO principle of inserting and removing elements, right? What is meant by FIFO? First in, first out. It is very similar to any queue that we see in our real life. For example, if you go to a, let's say, railway station or movie ticket counter to buy tickets, okay, and if there is a queue, what happens? So that in that queue, everybody is standing and you go and join that queue at the end of the queue. And the person who is at the first or the beginning or front of the queue is the person who will get the ticket first. And when that person gets the ticket, then he will come out of the queue and the second person will get a chance to buy the ticket and so on. And similarly, whenever your turn will come, you will get a chance to buy the ticket, and whenever you have bought the ticket, you will come out of the queue and new people will keep joining the queue at the back. Okay, so this is the queue in which first in, first out. If you are first one to join the queue, you will be the first one to buy the tickets. If you are the last one to join the queue, then you will be the last one to buy the tickets or come out of the queue. Okay, so FIFO principle is being followed by a queue, and queue is very intuitive data structure which you see in your everyday life, right? First come, first serve, or first come, first out. Okay, so now if we try to draw an analogy. So queue is a kind of container which is open at both ends. Okay, which is open at both ends, and the gate for entry and exit are different. So we enter the queue from the back and we get exit from the queue from the front. Okay, so we join the queue from the back, and whenever we are done, we come out of the queue from the front. Okay, so that is why first in, first out, right? First person will join here and it will be the first one to come out. Then second person will join here, second person will come out, and so on. Okay, so let's take an example. Let's say 1, 3, 7, 2, 5. These are the elements which I want to insert into the queue, right? So when I insert 1 into the queue, it will get inserted from the back and it will sit here. And once after that, if I try to insert 3, it will go from the back and will stand after 1. Then after that, 7 will enter the queue from this gate and will stand after 3. After that, 2 will insert Q from this gate and will stand at this place. After that, 5 will get inserted into the queue from this gate and will stand after 2. Now you saw, right? All the elements got inserted into the queue from the back. Now if I want to remove the element, so 1 is the first element into the queue, right? So it will get removed. So now before that, currently the front of the queue is 1, which is front, and the rear or back of the queue is 5. Okay, so whenever we remove element, it always gets removed from the front. Okay, so 1, if you want to remove element, 1 will get removed first, and after 1 is removed, 3 can be removed. After 3 is removed, 7 can be removed. After 7 is removed, 2 can be removed. After 2 is removed, then 5 can be removed. And let's say whenever we remove 1, then the front of the queue becomes 3 because 1 is already removed. So the front of the queue becomes 3. And this keeps on happening whenever we keep on removing elements. So is everybody clear with the functionality of queue? Any questions regarding the functionality, how it works, what is the principle that we follow, anything related to this? Got it. Okay, so if it is clear, then what we'll do, we'll try to understand the functions which we need to implement while we are implementing a queue, right? So we need to implement mandatorily two functions. One is the enqueue function, second one is the dequeue function, right? So enqueue is similar to push and dequeue is similar to pop. So what both of the function does, enqueue function inserts an element at the back of the queue. Okay, it will insert an element at the back of the queue, and pop or dequeue function will remove the frontmost element out of the queue. Okay, I'll repeat. Enqueue function will insert an element at the back of the queue, and dequeue function will remove the frontmost element out of the queue. So this is what will happen. Okay. Yes, it follows a linear flow. Linear flow means one element is connected to, after one element, the second element comes and so on, right? Uh, Yeah. So now coming back, somebody is asking what are the types of queues, right? So currently what we are studying is the basic queue, which is a FIFO queue. Other type of queues are priority queues and so on. But priority queues is implemented using heaps, which is a kind of tree. So we might study priority queues later. Okay. So currently we are studying the basic queues, which is FIFO queues. Okay, yeah. Pop removes the frontmost element out of the queue, right? So these two functions, along with other functions such as get the front element, get the rear element, or is queue full, is queue empty, all these functions you can implement along with this. But these two are the mandatory functions which you need to implement whenever you're implementing a queue. Okay, so now let's understand the implementation of queue with the help of a code snippet, which is there on the Geeks for Geeks site. So now here again, I created a structure called queue. In the queue, I have created an array called items array and front and rear to represent what is the front item and what is the rear item. Okay. So now this is a function to initialize the queue. Again, I am again passing the pointer to the queue and it is initializing front as -1, rear as 0 initially. That means the queue is empty. So now is empty. If you want to check if the queue is empty or not, you will check if front is equal to rear is equal to, sorry, if queue dot front is equal to rear -1. Okay, front is equal to rear -1, then the queue is empty. Okay, and is full if rear is equal to the max size, then we will say the queue is full. Okay, now the main operation, enqueue operation. Before doing enqueue operation, you will check if the queue is already full, will not be able to insert element inside the queue. Okay, so when we can print, okay, queue is already full, we cannot insert more elements and return from there. But let's say the queue is not full, what you will do, you will insert an element in the items array at the rear position. Okay, and at the rear position that will be inserted and you will increment the rear position by 1 after inserting it. Okay. Similarly, now coming to dequeue, you will check if the queue is already empty. Okay. If it is already empty, then you will print queue is already empty. We cannot get you we can not remove an element out of the queue. But let's say if the queue is not already empty, so what we will do, we will do queue front plus plus. That means front element is getting removed and the new front is getting changed to the next element. So this is what dequeue is doing. Peek, if you want to get what is the front element, frontmost element out of the queue, again you will check if the queue is already empty, then you will say okay, queue is already empty, I cannot get the front element. If it is not empty, what you will do, you will return the queue dot front plus one element, because we are following zero based indexing. Print queue will print all the queue, and this is the main function which is driving it. We are initiating a queue. We are declaring a queue. We are initializing it. Enqueue, then print queue, then enqueue, then print queue, and then at the end we might be doing some dequeue. Is everybody clear with the implementation of queue? Any doubts in the implementation of the queue?
Clear.
If this is clear, then what we will do, we will move on to the next topic. That is, let me see, that is a Q example I've already given. We'll go to the linked list, right? So what is linked list? Linked list is again a linear data structure. What is meant by linear data structure? Linear data structure, it means one node is connected to the second, second is connected to third, and so on. So these are arranged in a linear fashion. It does not happen that one node is connected to two different nodes. Okay, this is non-linear data structure. Okay, so if one node is connected to another node is connected to the third node, third is connected to fourth. So it is forming a, they are arranged in a linear fashion. Those are linear data structures. So now linked list. So linked list is again a linear data structure, which is a kind of a list. Okay. But in list, there are nodes which store the data, right? So what are nodes? So in linked list, there are nodes which store the data. Nodes are the nodes are the entity which store the data. For example, I want to store 12 here, 2 here, 7 here, 5 here, and so on. Okay. Now these nodes are connected to each other through some logical links. Okay. What are those logical links? I'll just explain you. So these are connected to logical links. Okay. Now what are these logical links? So inside a node, apart from the data which we want to store, there is one more element which gets stored, which is the address to the next node in the order. Okay. So address means pointer. A pointer to the next node is being stored in the current node. For example, the address of 2 is, let's say, the address of this memory allocation is 8. So the address of 2 will get stored in this particular node. That means 8 is the next node in the order. Similarly, the address of node 7, which is, let's say, some 12, will get stored into this array, and this address is getting stored, not array, in this node. Okay. Similarly, every node will store the data as well as the pointer to the next node, so that they create a logical link between every node. So now how they are connected, there is no physical link between them, but a logical link means every node stores the address of the next node. Okay. And the last node, okay, this 5, this does not have any next node because this is the last node. So what it will store in the place of address? In the place of address, it will store null, meaning that there are no more nodes after this node. This is the last node. And then in order to get the front of the linked list, or the, we have a pointer called head. So what head stores? Head is a pointer which stores the address to the first element. So it will store, let's say, address of 12 is 4. So it will store 4, meaning this is the address of this particular node. So we can start from head, which is at 4th location, and then we can see, okay, where is the next node? It is at 8th location. We'll go to the 8th location, then we'll go to the 12th location, and let's say the address of this is 16. So we'll go to the 16th location, and it will happen so on. And this is what is called linked list, because they are linked. There are nodes which are linked to each other, and these are dynamic in nature because we can keep on increasing or decreasing the size of the linked list by adding or removing nodes. So once we declare a linked list, it is not fixed in size. We can keep on adding or removing more and more nodes during the runtime. Guys, any questions? Okay, if there are no questions, we'll quickly see the implementation of linked list. Okay. So yeah, just now I'm going to tell how to create a node. So node is again will be a structure. Okay. So in which we will put data. Okay. Whatever data we want to store, this data can be some integer, this can be some character, this could be some other structure, it could be some enum, whatever you want to store. Now, the next thing that we will store is the pointer to the same node type. which will point to the next node in the order. Okay, so these things has to be stored inside the linked list node, right? First is data, data could be anything, and the pointer to the next node. Okay, we'll quickly see the implementation of linked list here. So you can see this is the node and this is how the pointer to the next node is stored. Okay, now coming to one more kind of linked list. So this was singly linked list in which we had a head, next pointer which is pointing to. The second type of linked list is a doubly linked list in which every node has two pointers. One to point to the next node, another one to point to the previous node. So for the first node, the next pointer is 2 and the previous pointer is null because this is the first node. So there is no previous node. So previous node is null. For 2, the previous pointer is 1, the next pointer is 3. For 3, the previous pointer is 2 and the next pointer is null because this is the last node. So this is how we can have doubly linked list. In singly linked list, we can only move in one direction, but in a doubly linked list, we can move in both the directions. Got it? Any questions? Another type of linked list is a circular linked list in which the last node, instead of having null, is collected to the first node. Okay, then it becomes a circular linked list. That means after the fourth node, again first node will come. So this forms a circle. That is why it is called a circular linked list. Guys, any questions related to linked list? Okay, if there are no questions, I'll quickly show you the implementation of linked list. So we can come directly here. Okay, you can see, right? We created a node, okay, in which we are putting data and the pointer to the next node. So create node, what it will do, it will take data, it will create a new node using malloc. Okay, it will assign data to the data field and next node will be initially null. Later on, you can change it to some other pointer to the next node, but initially it is null, and you will return the new node whenever you are creating a new node, and it will return the pointer of that particular node. Now here insert at first, if you want to insert a node at the beginning of a linked list, you will create a node, you will set new node dot next is equal to head, and then you will make new node is equal to head, and then head is equal to new node. Okay, so but all these things we will discuss later. I just wanted to discuss the basic implementation of a linked list. How do you create a node? Any questions related to linked list? Okay, if there are no questions, so linked list is clear to everyone, or any questions you can quickly ask before we move on to the next topic, revision of the next topic. Yes. If there are no questions, we'll move on to the next topic, which is trees in C++, and specifically we will discuss binary tree. Okay, so now all the data structures that we discussed so far were linear data structures, right? Which was stack, queues, linked list. Now tree is first non-linear data structure, or it is a hierarchical data structure, right? What is meant by hierarchical data structure? For example, in a college, right? A college or a school, right? The hierarchy is, right? Students report to a particular class teacher, right? And the class teacher reports to, let's say, head of department, and the head of department reports to the principal of the school, right? So let's say at the top of the hierarchy, this principal of the schools, right? and to principal, multiple head of departments will report, right? So HOD of mathematics, HOD of science, HOD of social science, and all the HODs will report to the principal. Okay. And to HODs, all the teachers of mathematics will report to the HOD of HOD1, HOD2, HOD3. All the teachers of mathematics will report to HOD of mathematics. And all the teachers of science will report the HOD of science. All the teachers of social science will report to the HOD of social science. Similarly, all the teacher and all the students will report to their class teacher and so on, right? So this is a kind of hierarchy which we have. Okay. And trees are the data structures which are used to represent these hierarchies. Okay. And most common type of tree that we see is a binary tree, right? So what is meant by a binary tree? A binary tree is a tree which can have at most two children, right? So it can have two or less than two children, at most two children. So this is a binary tree. So this is the root node. Root node is the which sits at the top of the hierarchy. That is the root node. Okay, let's say this is 5. And then it can have at most two children, a left child or and a right child, right? So let's say this is 7 and 2. Now every other node can have at most two children, which is left child and right child. So 1 and 9. Again, 2 can have left child or right child, and let's say 2 does not have a left child, 2 has a right child. So 2 will have a right child called, let's say, 4. So this is a binary tree in which every node is the entity that stores the data. Okay, like linked list, node was there in which we were storing the data. So in trees also, we have nodes which store the data. Apart from the data, it stores in a binary tree, it can store two things, a pointer to the left child and a pointer to the right child. This is for binary trees. Okay, because a left child could be present or a right child could be present or both of them can be null. Okay, but it will have pointers for left child and right child. If you put them to null, that means it does not have any child. But if they are not null, that means they have children. Okay. Any questions, guys, in the representation of in the concept of trees? The basic concept of trees, because trees are a very wide topic. We are just discussing the basic and basic implementation, right? The advanced we might discuss later. Guys, if you have any questions, you can quickly ask, right? It's better to ask questions than to not understand the topic. Cool. If this is clear, we'll quickly move on to the implementation of trees using linked list. Oh, sorry, implementation of trees. We'll quickly move on. So again, as I told, it will have a node. Okay. So we will create node using structure again. So this is a node structure for a tree, which will contain some data. This data could be anything. It could be integer, character, boolean, enum, another structure. It could be anything. Okay. Apart from the data, it will contain two pointers to the same node, which one of them would be the left child, another one would be the right child. Okay, so this node can have two children, which is left child and the right child, and that is why it is storing. Every node will have two pointers, left and right. If left and right are null, that means it does not have any children. If left is null and right is not null, but that means it does not have any left child but a right child. Similarly, if it's vice versa, that left has some child as left has some non-null value and right has a null value. That means it has a right child but not the, so it has a left child but not the right child. So now if you have to create a node, so basically what you will do, again, you will create a node using malloc. You will assign the data to the data field. You will assign left and right null because we are initializing the node. Okay, we can set left and right later on once the node is already created, and we will return the new node. This is how we will create a new node to be inserted into a tree. Now, if you want to insert that node into a tree, okay, so what you will do, first of all, you will pass the root node. Root node means this node, this node will represent the tree. So this node is being passed and the data that you want to insert. Okay, so now in this, what we're trying to do, we are inserting nodes from left to right. Okay, so for example, in first level, we filled this. The second level is also filled. In the third level, this and this is filled. The next node will come here in the left to right direction. So let's say if I want to insert 4, so it should come here according to this function. Okay, so what we are doing, we are creating a node. I told you, if the root is already null, so we will set the new node as the root node itself. For example, if the tree is empty, for example, if the tree is already empty, that means there is no node, not even the root node. So you can set the newly created node as the root node and you can return it from there. But let's say if it has root node. So what you will do, you will use a queue. Okay, you will use an array to create a queue. So this queue will contain the nodes because the type of the queue is node. So it will store the node type values, not the integer character, because the type of this particular queue is node type. And I will create a temp variable of node type. Okay. So now initially the front and rear will be set to equal to -1. That means the queue is empty and q plus plus is equal to root. We will insert the root inside the queue. Okay. So basically what we are trying to do, we are putting all the elements inside the queue. Firstly, I will put 5 and then I will see if 5 has left or right. Okay. If 5 has both left or right, then I will go to the children of 7. Okay. If 7 has both left and right, then fine. If it does not have 1, so I will put it there. And then once 7 is done, I will go to 2 and check if 2 has already left and right. But here 2 has already left. It does not have right. So we will insert the new element here. Let's say if you want to insert 3. Okay. So what we are trying to do, we are trying to check, put all the elements inside the queue to go to the next and next element. Okay. So while front is not equal to rear, okay, so we will proceed. Temp is equal to, so then we pop out the first element out of the queue and we check if its left is null, then insert the new node there. But if it left is not null, then we move to the next element. So we insert that particular left into the queue so that later on we can reach to child of this particular 7. Now we check if right is not right is null, we insert the new node there. And if right is not null, then we insert the right node into the queue so that we can visit its children later on. Okay, so this is how we do the insertion. And we keep on checking, and whenever we get a null, so now in this case, 7 will get inserted into the queue, 2 will get inserted into the queue. Now for 7, I will check, okay, both left and right are not null. So both of them will get inserted into queue. But for Q, for 2, this would be false because left is not null, but this will be true because right of 2 is equal to null. So what happened? Temp of right would be set to new node. We will insert the new node here as the right of 2. So everybody is clear on how we insert a node in a level order or in left to right way manner inside a tree. Okay, if this is clear, there are a lot of more things in tree like level order traversal, in order traversal and everything that we might discuss later on, but we wanted to just get started with the trees here so that we have a basic idea of trees, right? What are trees? How they look? What is the node look? How does the node look like? And so on. So if you have any questions related to that, then I'm happy to answer. Otherwise, I will move to the last topic, which is the graph. We will just discuss an introduction to the graph and we will wrap up this session. Cool. Now moving to the next topic, which is graph. Okay, so we'll just discuss a quick introduction to graph. Um, uh, Now, what are graphs? So graph is similar to trees, but the only thing is trees represent the hierarchical data structure while graph represents a friend structure. For example, in tree, so let's say there are three nodes, A, B, and C. So if A is reporting to B, A is reporting to B, oh my bad. So now in this, if B is reporting to A and C is reporting to B, so it can never happen that A is reporting to C because this is hierarchy. So in hierarchy, it can never happen. Okay, B is reporting to A and C is reporting to B and A is reporting to C does not happen. So this is what tree represents a hierarchical data structure. But in graph, if B is a friend of A and C is a friend of B, then C can also be a friend of A. Okay, so this friend relationship is represented by graph because it can contain loops. So tree is also a subtype of a graph, okay, or a subset of a graph which cannot have any loop or cycle. But in graph, the relationships can have loop or cycle as we just saw. So a tree is a subset of a graph which cannot contain loop. So all the trees are graph, but all the graph are not trees. That is true. So now, what is a graph? A graph is a set of nodes, and in graph we call them vertices or vertex as well. Vertex is singular and vertices is the plural. And these vertices are connected by edges, right? So these ABC are the vertices and the links between them is called edges. Okay, so everybody is clear about what is the structure of a graph. Now, the graph can be represented by two ways, either a adjacency matrix representation or a adjacency list representation. Okay, so for example, I'll just give you an example of how we can represent it with the help of adjacency matrix. So let's say my graph has three vertices and the name of the vertices are 0, 1 and 2. So let's say this graph is either this is 0, 1 and 2. Okay. Now in adjacency matrix representation, the size of the matrix will always be n cross n. So these are three nodes. So it will be a 3 cross 3 matrix, 0, 1, 2 and 0, 1, 2. And all the elements will be initially 0, or you can say okay, we can say 0. 0 means there is no link between the nodes. So now here currently there is a link between 0 and 1. So we will go to the adjacency matrix. We will see where 0 and 1 is. So this index is 0, 1. So I will update it to 1, representing there is a link between 0 and 1. Similarly, there is a link between 1 and 0. So 1, 0 will also get updated and it will say that there is a link between 1, 0. So 0, 1 and 1, 0 both there is link because this is a bidirectional or undirectional graph. That means 1 is connected to 0 and 0 is also connected to 1 through the same edge. If it was a directed edge, that means if it has an arrow, then we will say only 1 is connected to 0, 0 is not connected to 1. But currently we are taking it as undirected. Similarly, there is a link between 0 and 2. So we'll go to 0, 2 and 2, 0 and set is at 1. 0, 2 and 2, 0. Both of them will be set to 1 because they both have link. Now 1 is connected to 2. I will go to 1, 2 and 2, 1. So 1, 2 is this and 2, 1 is this. So both of them are connected. So 1 and 1 will come. So this is the adjacency matrix representation of this graph. And you will see for a undirectional graph, this adjacency matrix will always be symmetrical across this particular diagonal axis. You can see this diagonal axis, this is symmetrical. Fine. Now there is another way to implement graph using adjacency list representation that we'll see just here. So here what we did, firstly, okay, we use adjacency matrix representation here. Okay, so you can see if there is a graph of edges v cross v. So we created a matrix v cross v and initialize everything to 0. If I have to add one a link between 0 comma 1, so I will call a function called add as 0 comma 1. So what 0 comma 1 will do, so it will make 0 comma 1 is equal to 1 and 1 comma 0 also equal to 1. That I was doing. I want to add an edge between 1 comma 2. So what it will do, it will make 1 comma 2 and 2 comma 1 is equal to 1. Initially everything was 0. And if I have to print graph, I can print graph in this way. Okay, so these are graphs. This is how we represent graph. So do you guys have any questions related to graph? So there are more things about graph, such as how do we so this, okay, for implement, okay, one thing, this was adjacency matrix. Now we will discuss adjacency list representation. So one thing I missed, adjacency list representation. So what happens in an adjacency list representation, this graph, there will be a list, okay, which will have 0, 1 and 2. Okay, and this will have their own list. Okay, in the list of 0, all the elements which are connected to 0 will be there. So in the list of 0, what are the elements which are connected to 0? 0 is connected to 2 and 0 is connected to 1. So 1 will come in the list of 0 and 2 will come in the list of 0 because both of them are connected to 0. Similarly, in the list of 1, all the elements which are connected to 1 will be there. So 0 is connected to 1 and 2 is connected to 1. So they will come. In the list of 2, all the elements which are connected to 2 will come. So 0 is connected to 2 and 1 is connected to 2 will come. So this is the adjacency list representation. Okay. So now you can see in adjacency list representation, what we did, we created a graph. Okay, so this graph is a structure and this structure contains what is the number of uh, what is the number of vertices or the nodes, and then it contains another structure which is the adjacency list array. So in the adjacency list array, it contains the destination and what is the next adjacency node. Okay, so destination, so basically this is the array of array. Okay, and it will tell you what is the index of this particular, this destination will tell you what is the index of this particular node in this array, and this will tell you the list. So basically this array is this adjacency list node and this array is this, which is adjacency list node of itself, which will contain what is the next element. So you can see while creating a graph, I initiated V. So V gets initialized. Okay, the number, the array of array list gets created of size V, and the destination would be equal to, sorry, this initialize, where is, okay, create graph. So V will get initialized to whatever value we passed V, and then malloc will create the graph first of all, and the array list will be created using the calloc, and everything will be initialized to 0. Fine. Now, if you want to add an element, add an edge. So what we will do, we will add an edge. Okay. So we will put that element in the array with the destination and source and destination we will put. Okay. So we will go whatever is the destination node. I will find the list of that, and in the list of that, I will insert the source. Is this clear, guys? So basically what I'm trying to do, first of all, I am finding, whenever I'm trying to do, this is the destination. Okay, what is the list of the destination? This is the list of the destination. And in the list of the destination, we are inserting the source. Okay, guys. So this is it about the graphs. If you guys have any questions, you can ask me. I'll try to answer those questions for you. We just discussed very basics of every topic that we had, and it was all revision of whatever you had studied during the whole week. Okay. Now, if you have any doubts, you can ask, and I will just ask you for the next week topic. Just be regular and keep reading the articles that are there for the next week topic, so that we can, whenever we are doing the revision, you are just aligned with everything because you've already read it. Okay, so we'll do the revision like this. Fine. Any other questions you have? Okay, if there are no questions, then thanks for joining, guys. We will conclude this session for today. And this was the revision of the week 3 topics that we studied. And thank you all, guys. Thanks for joining. Bye bye.